In this video we're going to be looking at the concept of a statistic. The definition of a statistic is a quantity calculated solely from the observations in a sample. It does not involve any unknown parameters. That is, a statistic is a numerical property of a sample. So the objective today is to find out whether we can spot a statistic or whether something is or isn't a statistic just by looking at it. So we need to firstly know what unknown parameters are, because these are mentioned in the definition here. It doesn't involve any unknown parameters. So let's have a look at what these are. Well, they are population parameters. So population parameters are unknown, and these include measures such as the population mean, which is given as mu, or the population variance, which is given as sigma squared. Indeed, the standard deviation, which is just sigma, is also a population parameter. So those are unknowns. The notation that is used for things that are known, so in a sample, so the sample mean is not given as mu, instead it's given as x bar. So that's something that's been measured. And the same with the sample variance. So the variance of a sample is normally given as small s squared. So these are things that would potentially be in a statistic, and these ones are not part of a statistic. Now, let me try and bring this idea forward. So imagine that we needed to do a survey on the lengths of ants in Hackney. Now, obviously, all the ants within Hackney, every single ant that is living in Hackney at the moment, all of them will have a mean. They'll also have a variance, but there's no way that we can measure these. So this is a population parameter. This mean, the mean of all the ants, and the variance, and even the standard deviation of all the lengths of ants in Hackney is unknown. So instead, we'd have to take a sample and generate statistics about the length of ants in Hackney. So if I randomly select some ants to be our test subjects, we could start generating statistics about them. So I could find the sample mean of this group. So that would be x1 all the way up to xn, the number of ants that I've chosen, divided by n. That's going to give us our sample mean, and that is a statistic because all of these values are known. We know the length of each ant because we would have measured them in our small sample. We know the number of ants that we've got, and that will generate us the sample mean. We could select just a few, so I could select maybe the first one, the fourth one, and the fifth one, and then find the mean of those. That is also going to give me a statistic because we know all of these values. Even if I wanted to find, say, the standard deviation or the variance of this sample, that would still be a statistic. So let's say I was finding the variance. That's going to be the sum of all of the ants, or each ant, minus the sample mean, squared, and then divided by n minus 1. That'll give us the sample variance. If I was to square root that, that would just give us s. Still be a statistic because we still are able to know all of these values. So let's start looking at some random statistics that are not, or random formulae that are not statistics. So something like this, the sum of xn minus mu over n is not a statistic. X bar minus 2 times the standard deviation, the population standard deviation, is not a statistic either. Anything that contains either the population mean or the population standard deviation or population variance makes it not a statistic. So when you have a set of questions, that's what you need to look out for. Does it contain either of these two symbols? If it contains either of those, in whatever form, this one may be to the power of 2, might be the square root of something. If it contains those, then it is not a statistic because it contains a population parameter which is an unknown parameter.